In this video, you guys, I would like to show you how to do names and formulas for polyatomic ions. Poly means many, so we've got two or more, and this is similar to what we did for the binaries. Bi meaning two, those were just two elements. Now we have compounds with three or more, and so we have to tweak things just a little bit. We still put the positive ion first, negative ion second, but now we have to take a look and note that here we've got some things in parentheses, and that's considered polyatomic. And so that's just going to change a little bit in terms of how we name these. So we have to pay attention to those parentheses and do things just a little bit differently. So we take a look at the first one, items in parentheses. We're going to go to the last spot on our periodic table that we haven't used. I've got NH4, and so I go to my periodic table, and we have not used this table yet. And so now when we're doing polyatomic ions, we're going to come into this table to get the oxidation number and the name. We've got the name on one side, oxidation number on the other side for that, along with the formulas. And so now I'm looking for NH4. That one happens to be right on top. Ammonium. And what I'll do is I'll take the name from this table, and I won't change the spelling. Take it exactly as you see it. So ammonium, I'll take that word and I'll go over here. Ammonium. And then I have this Cl. We've seen that before. Cl is chlorine. I'll go back to this sheet. We go back here, and Cl is chlorine. And I'll just call that chloride. That's it. I'm all done naming that one. Sometimes what students will do for the parentheses, they will do this. They'll call it nitrogen-hydrogen chloride. They will go and name the individual elements. That's not correct, because NH4, when they are together, NH4 is called ammonium. So when we see those elements in parentheses, we have to come to this table, look for the name, and that's the name that we use. We don't ever list the elements separately. I'm going to get rid of that just because it is not correct. I just wanted you to see that we don't do it that way. We'll do one more. We'll go down to number 3, Ca. Go to my periodic table. Ca is calcium. There's calcium, capital C, lowercase a. So I'll go back here. And then notice this CO3 is in parentheses, so I'll go back to my periodic table and use that table. And I'm looking for CO3 in parentheses. CO3 in parentheses is, right, here we go, here it is. CO3 in parentheses is called carbonate. So I'll take that name again. Do not change the spelling. I'll take it exactly as I see it. That's it. I'm all done. That's calcium carbonate. That's naming a polyatomic ion. And I would just repeat the process for the rest of the page. Formulas. Again, this is similar to what we saw before. What we did with the binaries, but these are now polyatomic. So again, we're going to be using those ions in the parentheses. And so I'll start out with number 11, positive element first, aluminum. I'll get the oxidation number momentarily. And then we've got hydroxide. That's not an element, that's polyatomic. So I'm going to go to my periodic table. I need aluminum's oxidation number, and I need the formula for hydroxide and its oxidation number. So hydroxide sits right here, so I need OH in parentheses and a -1. And remember, I also needed aluminum's oxidation number. And so I'll come here. Here's aluminum. Aluminum, we already have the Al, and it's a +3. So I have OH with a -1, and then Al is a +3. So Al is a +3, and then I said it's OH with a -1. Now that I've got that, I crisscross just like I did before. The only difference is when I crisscross outside the parentheses. So I'll take that 3 outside the parentheses, crisscross that 1, and remember I put that 1 there, but remember we don't ever show the 1. Oops. There's my formula for aluminum hydroxide. Again, we'll do one more. Let's jump down to number 15. Let's do zinc with the 2 in parentheses. No, let's jump down to 17, iron 2 sulfate. So let's jump down to that one. So I need iron with the 2 in parentheses and a sulfate. So I'll go back to my periodic table. There we go. So iron with the 2 in parentheses. I've got iron. Oh, this one we looked at not too long ago. So iron with the 2 in parentheses. So it's got a +2 oxidation number. And sulfate. There's sulfate. So SO4, and it has a -2 oxidation number. So I'll take that information back. And so let's try purple. Iron had, with the 2 in parentheses, has a +2. Sulfate was SO4. That also had a -2. And so now we crisscross. Last item, when the subscripts are the same like this, a 2 and a 2, just like in math class, we can simplify those down. A 2 divided by 2 becomes a 1, and so I can eliminate those 2, and we just need 1 of each. And there's our correct formula. It'd be the same if it was a 3 and a 3. We would simplify that as well. If we had something like this, for example, aluminum +3, nitrogen -3. Well, the 3 and the 3 simplifies down. There's our correct formula. So that 3 and the 3 would simplify down as well. So if we've got similar subscripts, we can eliminate those. And that's how we do formulas for